A can of engine oil with a length 150 millimeter and diameter of can given 100 millimeter is placed vertically in a trunk of a car. In a hot summer day, the temperature of the trunk is 43 degrees Celsius. Say temperature, the trunk is 43 degrees Celsius. If the surface temperature of the can is 70 degrees Celsius, determine the heat transfer rate from the can surface and neglect the heat transfer from the end of the can. So we need to calculate the rate of heat transfer, and formula for rate of heat transfer is heat transfer coefficient, then can surface area, then temperature difference between environment and the can surface. So here temperature is given, so we can calculate the temperature difference, and the surface area for the can we can calculate from pi dl. So pi diameter given 0.1 meter, length given 0.15. So easily we can calculate the surface area for cat. And let me check how much this value. Pi times 0.1 times 0.15. So 0.0471 meter square. Now only we need to calculate the heat transfer coefficient. Now for heat transfer coefficient, we need to calculate the Nusselt number. Now for Nusselt number, we need, due to the natural convection heat transfer, we need to find out the Rayleigh number. For Rayleigh number, we need to get the properties of fluid. Here is a air, so we need to calculate the properties of air. So here's first, say for this problem we will solve based on some assumption. First one is steady operation condition exists, then air is an ideal gas and thermal properties are constant and radiation heat transfer is negligible. Now we will find out the properties of air at film air, average of surface air and the environment air is 30 degree. Now for property table for air is, say, air table A14 or say 15, properties of air at 1 atmospheric pressure at 30 degrees Celsius. So from here we'll calculate the, which will use the kinetic viscosity. So this one 1.608 10 to the power negative 5. Then we'll correct the thermal conductivity 0.02588. Then Prandtl number 0.7282. So viscosity, thermal conductivity, and Prandtl number. Now beta is 1 over the temperature in Kelvin. So 1 over 30, if you convert to the Kelvin, it will get the 303. So 1 over temperature, mean temperature in Kelvin. Okay, now we have the all properties. Now we can calculate the Reynolds number from this formula. Say gravitational acceleration, beta temperature difference, then length cube times Prandtl number over the viscosity square. Now, if you use all of values here, say 9.81, 1 over temperature in Kelvin, then is given is 43 minus 17, length of the can is 0.15 meter cube, Prandtl number is 0.7282 over viscosity square 1.608 times 10 to the power negative 5 then whole square. So we'll get the values is 8 times 10 to the power positive 6 for this problem. Now this one is vertical can means vertical cylinder. So here is a table 9a. It's a vertical cylinder. We can treat as a vertical plate when the diameter of vertical cylinder equal or greater than 35 L, then GR L to the power 1 over 4. If satisfied this condition, then we can treat our this vertical can as a vertical plate. Then based on vertical plate, we will find out the suitable Nusselt number formula. Now we'll check this one. So here 35 is the length is 0.15 and GRL for this problem is 1.099 10 to the power 7 1 over 4 and it is equal to 0.0912 and which is get less than diameter. That means this problem satisfies this condition. Our diameter is higher than this value. Diameter, yes, 100 millimeters, so higher than this one. So now if higher than this one means this problem we can treat as a vertical plate. Now in vertical plate formula, so this one the vertical plate formula and our number is 8 10 to the power positive 6. So between this range, the first range, so we will use the equation number 9.19 for the Nusselt number. So based on our Reynolds number, we'll use this formula to calculate the Nusselt number. Okay, Nusselt number here will be 0.59, then Reynolds number to the power 1 over 4. Yeah. So here, so we'll get 0.59. R was 8 10 to the power positive 6 1 over 4. It will give us 31.38. Now heat transfer coefficient we can calculate from K times Nusselt number over the length of the can from this formula. So here K thermal conductivity is 0.025 88, Nusselt number is 31.38 and over 0.15. So it will be 5.414 watt per meter square Kelvin. Okay, now we got the heat transfer coefficient. We can calculate the heat transfer rate of heat transfer from the can. Formula is H, surface of the can, temperature difference. So this one is 5.414. This one we already calculate is here area. So 0.471. 0.0471 temperature difference will give us 6.63 watt.